Hello everyone, my name is Darshanti. I'm from the Department of Basic Science, studying third sem Computer Science and Engineering. So today my topic is stack operations. So introduction to stack operation. Introduction to stack operations. A stack is a linear data structure that follows the LIF means LIFO means last in first out principle. Stack operations involve adding and removing elements from the top of the stack. Common operations on a stack include push, pop, and peep. Also display. So main thing will be push, pop, and peep. There will be three common operations, which is of push, pop, peep. It can be represented p cube for hint. So push operation. When we come to the push operation, what is push operation? Uh, Pushing an element into the stack. So push operation adds an element to the top of the stack. The new element becomes the top element of the stack. It increases the size of the stack by one. So in nothing but adding an element into the top at the top. So next pop operation. Pop operation is nothing but deleting. Pop means deleting. Pop operation removes the top element from the stack. The element that is popped is returned and no longer belongs to the stack. It decreases the size of the stack by one. So pop is nothing but removing an element from the stack at the top, and element is returned and no longer belongs to the stack. It decreases the size of the stack by one. Next, peep operation. Peep operation means returns the top element of the stack without removing it. It allows us to examine the element at the top without modifying the stack. The stack remains unchanged after the peep operation. Okay, it is nothing but peep operations returns the top element of the stack without removing it. Without removing the top element, I'm gonna display the values from the top to the bottom. It allows us to examine the element at the top without modifying the stack. Without modifying the stack can be examined. Elements can be examined. The stack remains unchanged after the peep operations. The stack is remains stable. There will be no changing. So stack underflow. What is stack underflow? When an element is pushed into the stack, if the size of the stack is maximum. For example, if you take maximum of 10 elements, and if you want to insert 11 element, then it can be overflow actually. Underflow means opposite to that. Underflow means when there is no element in the stack, then you have to insert it, then there will be underflow. For example, you can see a stack underflow occurs when a pop operation is performed on an empty stack. It is an error condition indicating that the stack is empty. Handling stack underflow requires appropriate error checking. So when there are no elements in the stack, then also you have to remove some element, then there will be underflow, which will be represented by -1. So overflow, as I said the past, you can see here overflow occurs when a push operation is performed on a full stack. When there is a full of elements in the stack in which is no more space, then you want to insert the element, then it can be the overflow. It is an error condition indicating that the stack has reached its maximum capacity. Handling stack overflow requires appropriate error checking. Okay, stack operation occurs when a push operation is performed on a full stack. It is an error condition indicating that the stack has reached its maximum capacity. Handling stack overflow requires appropriate error checking. So we seen pop, peep, and push operations in stack. What is stack? And let's see some of the applications of stack operations. Stacks are widely used in programming languages for expression evaluation. It's mainly used in many programming languages like Java, Python, C, C++ for expression evaluation. They're used in functional calls, functional calls and recursion to store return addresses. They store the return addresses. So it can be used in function calls and recursion. Undo or redo functionality in software applications can be implemented using stacks. So applications here you can see there are major applications which will be used in programming languages for expressing or expression evaluation. They are used in functional calls and recursion to store return addresses. Undo and redo functionality in software applications can be implemented using stacks. So what are the implementations of stack operations or stacks? Stacks can be implemented using arrays or linked lists. Okay, using arrays and linked lists only, stacks can be implemented. Why not other? Arrays-based implementation allows for a fixed size stack. Linked list-based implementation allows for a dynamic stack size. So summary. After application, we're going to see summary of stack and stack operations. Stack operations involves push, pop, and peep operation. As we know, push adds an element to the top, pop removes the top element, and peep returns the top element. Okay. And then stack, underflow, and overflow are error conditions to be handled. When is overflow, there is no element in the stack, and you have to remove an element or pop an element, then there will be uh, underflow. When there is overflow, overflow means when there is full of elements and still maximum size it has reached and still you have to insert it, then it can be overflow. So here I end with summary. Thank you for watching.